Good afternoon. Today we're going to continue covering the topic we started last time, interrupts. We're going to talk about how to program interrupts, and we're going to really program an interrupt through a class demo, a hardware interrupt. But before we do so, we're going to look at what is an interrupt vector. We mentioned it quickly last time. What are priorities of interrupts? What other kinds of exceptions, interrupts among them? And today we're going to cover the first kind of interrupt and do it on the board together. A hardware interrupt called IRQ interrupt. So last time we introduced the concept of what is an interrupt, and we said it is something that interrupts the normal flow of a program. Okay, I don't see something you see on what? Okay, this is the new. You see my screen, right? And I don't know, PowerPoint is doing that, or okay,
Title maybe.
Doesn't matter. It doesn't hurt. You're okay with that. You see the typing, right?
No, actually, maybe subtitling. What you are saying is.
Did I? Yeah. I didn't choose it. Okay.
Fine. Just here next to يعني بالباوربوينت نفسه.
بالباوربوينت.
هاي جنبها هاي اللي فاتح عليها جنبها CC.
Okay. Thank you. I didn't know that. طيب. So an interrupt is something that is supported by hardware that interrupts the normal program flow, taking the program counter to a piece of code out of sequence, asynchronous. We don't know when to execute something in response to an event. The event can be a hardware or a software event, but it has to be supported by the hardware to force the program counter to go to the new place and to save the CPU status to be able to go back to normal execution when the interrupt source disappears. Okay. So the steps to program an interrupt. First, we need to initialize the interrupt vector. The interrupt vector, we said last time, is to tell the CPU where is the code that you wrote for the interrupt service routine, the code you want to perform. This is code you write, the code that you want to run when an interrupt source happens. Where is it? Where did you write it? Just like a function, you know, a function or a subroutine, you tell the program where it is, at what memory address. You tell it go there and execute that code. Now, an interrupt is, we don't know when it's going to happen. So you need the hardware to know where you wrote the code. So you initialize the interrupt vector, and we're going to look at that. Then inside the interrupt service routine, we write our code that we want to happen in response to the interrupt. After writing the code, we enable interrupts so that the CPU starts responding to the interrupt source. So these are the three steps now. This is for the first interrupt, the hardware interrupt. Later on, with another type of interrupts, and only if we exclude the hardware IRQ interrupt, at the interrupt service routine, you need to clear an interrupt flag, something called an interrupt flag, so you don't come back again to the interrupt service routine. I'll talk about that later. Interrupts have an overhead, which means if I have a hardware interrupt, a falling edge that happens due to pressing a button, for example. When you press the button and cause the falling edge to happen on a pin of the microcontroller pins, this will cause the program counter to go execute some code you wrote in the interrupt service routine. Going to execute that code, going out of your sequence, executing that code, okay, and then returning back, how much time does that cost? And what is the overhead, efficiency speaking? The overhead is you have to save, when you change your sequence, all CPU status registers and program counter and stack pointer and everything. And when you return, you need to restore them back. So here you have a bunch of push to the stack, right? All registers. And this will take time. We know pushing every register will take this amount of time. Then restoring them, this will cause a pull of all registers from the stack. This is an overhead. And if I ask you to give me in numbers, what is the amount of time in terms of clock cycles or microseconds, if I give you the oscillator frequency, you should be able to compute this. Then, when you're there, your program counter is at the interrupt service routine. Before you get your program counter pointing here, you had a bunch of pushes to store the CPU status. You send your program counter, you execute. The last instruction in the interrupt is called return from interrupt. A return from interrupt will cause the restore, of all registers you push to the stack. Okay, then you execute all the instructions in the interrupt service routine. You can compute them if I give you the code. Then the return will cause the pulling the register from the stack and restoring the value of the program counter to the return address. This is all overhead, okay? And if I give you code and clock frequency, you can calculate the time. Resets is a kind of interrupts, but sometimes in some literature, they like to separate it, call it a reset. A reset, we know that it is something that causes the program counter to go point to the first instruction in the program, not to a clear interrupt service routine or a separate interrupt service routine. So program counter, a reset, actually interrupted the normal flow of the program counter, okay? But it didn't go back to the interrupt service routine. It didn't go to an interrupt service routine. It went to the first instruction in the program, okay? So that's a reset. And a reset could happen manually when you push the reset button, okay? Something like this. Here, there is a pin, a reset pin in the microcontroller. It is usually pulled to high. When you push the button, you short it to ground. This will be low. This will cause a reset. This will cause the program counter value to go to the first instruction in your code. And we initialize, we tell the program, the microcontroller, where is the first instruction? We tell them that by the interrupt vector. And if you remember, I'll jump really quick and come back. This table, there is something called a reset here. You see my slide? Do you see the writing on the screen? Reset, the first thing. What is this number vector address? FFFFE, this one here. You see it? Yes, no?
Yes, Dr. Shafin. Yes.
Okay. Okay. And if you go back to the code we used to write together, let me just open one of the code, this one, class demo 1, the first time we wrote a program or two, an assembly program. Let me open this project real quick. In our assembly program, we used to have something in the bottom here called interrupt vector. And at address, we said at address origin, FFFFE, define a constant word and write in it entry. Entry is here, which is a label. When we assemble our program, this is converted to a number. It is actually origin RAM start. RAM start is 4000. So 4000, we're writing in this location, memory location, FFFE, the value 4000. So whenever a reset happens, the program counter will go point to address 4000. Okay. Now later on, when we want to do an interrupt service routine, we may write it here, or up, or down, or whatever. We need to give it a label, and at its interrupt vector origin. For example, if we go do this interrupt, the interrupt for مثلا for IRQ interrupt address should be at address FFF2. Okay, here FF2. We should write our interrupt service routine, okay, and come here and say origin $$ FFF2 and say define constant word my IRQ interrupt service routine مثلا. وانت تكون you before that you write something here called my IRQ interrupt service routine and you write your code here. Okay, and the last thing will be return from interrupt. Okay, so that's why I told you when we were writing code, don't touch this piece, because if you remove this line or change this value, a reset will cause going to a wrong place that is not the beginning of your program. Okay, طيب. I'm not going to save this. So when an interrupt happens, IRQ interrupt, I want the program counter to go here. When a serial communication interface interrupt happens, I want the program counter to go to an address I save over here. Sorry, I save over here. So when a reset happens, the program counter doesn't go to FFFE. It goes to FFFE, finds something stored in there. That's the address of the code, where the code is. طيب. So the only difference between a reset and an interrupt is that a reset does not save the CPU status and the return address. You cannot return. ماشي? A reset just makes the program counter go to the first instruction, to address 4000. That's it. That can be either manually or it can be a power on reset. Why do we need to do a power on reset? Yani, when you first power on your microcontroller, you need to do a reset. Why? Because you don't know what's the value of the program counter, right? And you want, when you start your controller, to start executing the program from the first instruction. So you have to do a reset. But I don't want to do the reset real quick, immediately, and start running. I don't want to just power my controller and start running, because the controller, sequential circuit, it's a bunch of registers of flip-flops that have initial values. Flip-flops take time to stabilize, right, to get to its final value. So the microcontroller, even power, some circuits in the microcontroller need some time to stabilize and start functioning correctly. Okay, so at power on, we need to do a reset and hold that reset for a certain amount of time with some delay, then release it to start executing. So a circuit like this one could be useful. You can, when you first power this, initially you're at ground. You're not to rise to high. Okay, so you're at reset. When you power this capacitor, this RC circuit will cause this capacitor to start charging, right? Until you get at the end to this level, to a high level, the reset goes away and the program counter starts moving. Okay, while the reset is down, is low, the program counter is stuck at the first program instruction. Okay, a reset is non-maskable, which means there is no way to avoid it if it happens. So a reset interrupts.
دكتور سؤال ممكن؟
Yes, Mustafa.
لا المانيوال ريست اللي هو البوش بوتن تاع الريست.
Yeah, something like the push button we have here on our microcontroller. This is actually this same circuit, this button.
Okay.
Okay. Now, last time we talked about maskable and non-maskable interrupts. Interrupts you can mask, and you can disable. Interrupts you cannot mask, non-maskable. Examples of maskable interrupts, the IRQ interrupt that we're going to deal with it today. Examples of non-maskable interrupts, you cannot disable them. If they happen, then they happen. They will interrupt the CPU, okay? They will interrupt it, like the IRQ pin interrupt. This is non-maskable. A software interrupt instruction, non-maskable. Unimplemented code trap is non-maskable. Okay. Another kind of exception is a reset that we just talked about. Okay, a reset. A reset could be caused by a manual reset. Okay, could be caused by a power on reset. These are the two cases I covered here. 1, 2. Mashi. And there are COP resets. Computer operating properly reset, or watchdog resets. And I mentioned that before. A timer that runs in the background, if it reaches its maximum and overflows, it will cause a reset. So in your code, you shouldn't allow it to reach the maximum. You should go feed this dog. You should go reset it manually in your code, so you don't allow it to get it to its maximum. Okay. And a clock monitor reset, a hardware circuit inside the controller. When we talk about the clock monitor and the CRG block, I'll mention it. Something that if it sees that the clock is not stable, it will cause a reset. So these three things are called exceptions. Interrupts, maskable, non-maskable, and resets are exceptions. Exceptions, why? Because they're exceptions. The norm is the program counter has a normal flow. An exception, it goes to somewhere else. Okay. Questions so far? Maskable interrupts. Maskable interrupts are a type of interrupts that can interrupt the normal flow of the CPU, send the program counter to execute some code off sequence at any point of time, okay, that you don't know about as a programmer or as a software engineer. But you have the option to disable it when you want. You disable it, you mask it, okay? You mask it. And the mask could be a local mask or global mask. If you remember, when we studied the CCR register, this code condition, the code condition register, there was a bit called an I bit, right? I bit, if you clear it, clear CLI, you clear this bit, and you write a 0, you're enabling interrupts. All maskable. This is for maskable. Enable all maskable interrupts if you write a 0 in it. In case you write a 0 here, if you clear this bit, and there is an assembly instruction to clear it. If you set it, okay, if you set this interrupt, there is another instruction to set it, this bit, you disable all maskable interrupts, and you mask them, okay? This is a global. You're enabling or disabling all maskable interrupts. And if you look at this table, we'll come to it. So starting the IRQ here, interrupt number 6, downwards, these are all maskable. That bit will disable all of these or enable all of these. Okay. And there was another bit in the CCR register for the non-maskable interrupts. I think it was the X bit. And this is non-maskable. You are allowed to unmask the unmaskable interrupts once at the beginning of your program, but you are not allowed to mask them again if you do so. You have to reset to be able to reset, to be able to mask them again. But for maskable interrupts, you can go write this bit at any point of time, change it, make it a 0 or a 1. It will affect all maskable interrupts. What do I mean by local mask? Some interrupts have a local enable or a local disable. In some register, you can enable this interrupt on its own. You can enable it or disable it on its own, giving that the I bit is cleared, yani the global enable is enabled. Okay. طيب. Guys, if you have questions, please stop me. Let's assume that two interrupts happened at the same time, the IRQ interrupt and the SPI 0 interrupt. They happened exactly at the same point of time. The program counter is just a single register, right? It's gonna go to only one place. It cannot go to two places. So you can only serve one interrupt service routine at a certain point of time. What is that going to be if two interrupts happen at the same time? It's going to be the one with the higher priority. The one with the higher priority. Now, maskable interrupts, priority is according to this table. It is according to its, let me clear what's on this slide. Clear screen, how do I clear? How do I clear ya shabab? Erase all ink on slide. Okay, ماشي. So if one interrupt happens, another interrupt happens, this is of higher priority. Higher priority. Yani as you go higher, you have higher priority. So an interrupt that has an address in the vector address, in the interrupt vector, the higher the address is, the more priority the interrupt has. And this is the CCR mask, if you see. All these bits have the I bit in the CCR code register. You have to make it 0, sorry, to make these work. Otherwise, if it's 1, they don't work. The external interrupt, the X bit in the CCR register, only affects this one. Once you enable the non-maskable interrupt, the XIRQ, you cannot disable it again unless you do a reset. All of these SWI up to the reset, these are non-maskable. You cannot mask them at all. You cannot mask them. You cannot stop them. If they happen, they happen. The higher priority is the one with the higher address. Talking about maskable interrupts. The non-maskable, I have them for you in the data sheet. For the exception priority, the highest priority is a reset. Okay, then a clock monitor, the clock is not operating properly. The watchdog timer is the third priority. Unimplemented code, software interrupt, then XIRQ. This is the priority we have for the non-maskable interrupts. Okay, I meant to go copy them from the data sheet because they're not in the same order here in the table. They're not in the same order here in the table. So, are they? COP and implemented software IRQ. COP and implemented software IRQ. Well, yeah, نفسهم, but they're not here. COP and software IRQ. Are they? Anyways, these are clock, COP, and this is the priority for maskable. For non-maskable. For maskable, the one with the higher vector address, it has higher priority. But you have the choice to go pick any maskable interrupt. Okay, you have the choice to come raise the priority of this interrupt. For example, the SPI2. If you think in your application this should be the higher priority, you can go raise it. Okay, make it the highest priority, regardless of its address. By what? By taking the lower 8-bit of this address and saving it in a register called high prio register. Okay, you just go save it here. You say high prio register equals 0xFFF. مثلا, which one do we want? We want this one, D6. You just say here D6. You write it in this register. Now, if this one, if D6 interrupt, which is this serial peripheral interface, happens, or this one, and this one happens, in the normal case, the IRQ is higher priority. But if you write the lower 8-bit of this vector address of any of these lower ones in the higher priority, it will be raised to the higher priority. Okay, and this is available only for one. You can pick only one to raise it to the highest priority. Okay.
Doctor, there is a default value for this register, or
the default value? Wallahi, good question. I didn't test it. It could be, if it's 0, let's assume it was zeros. would it affect anything? If it was zeros, we don't have any interrupt that ends with zero, right? So it doesn't matter. It could be zeros. Usually defaults are zeros. We need to check it in the data sheet if it's there, or just test it. Yeah. Okay, but the default is the priority over there. Okay, we talked about these things. Now we're going to start with the first interrupt. Before we start with the first interrupt, I just wanted to show you this table. This table, I took it from it is table 6.1 in the book, okay? And I added a new slide. So this table is exactly this same table, but I took this from the data sheet. I took it from the data sheet because it has this column. This column, the second column is not here. You see it? Here we only have the vector address and the interrupt source. This table has the vector number. We're gonna need this number when we write C code. We need this number when we write assembly code for interrupts. This number is for C code. Okay. So today, now I'm gonna start talking about the IRQ interrupt. The IRQ interrupt, this one, which is interrupt number 6, okay? And if I write in C, I have to initialize, put its interrupt service routine address in address FFF2. Okay. What is the IRQ interrupt? This is the only external maskable interrupt for HCS12. There is another one non-maskable, external. We can generate, though, interrupts through external pins, using different ways when we come into timers, okay, input capture. But a standalone, clear external interrupt is the IRQ interrupt. It is edge triggered or level triggered. This is something we can define. Edge, yani it will cause the program counter to point to where the interrupt service routine is at when an edge, a falling edge or rising edge, is detected on one of the pins, okay? The IRQ pin, we call it the IRQ pin. This IRQ pin is usually shared with port E bit 1, okay? Port E bit 1, you can use it as a parallel port or you can use it as an IRQ pin, an interrupt. IRQ is short for interrupt request, okay? IRQ. When do we use it as an IRQ? There is an enable bit for IRQ. Once enabled, it is an interrupt pin. If it's disabled, it's a parallel pin. The registers to control this is called the IRQ Control Register. We're going to look at it here. So it is interrupt number 6. The register here's this register is the IRQ register. IRQ. What was the name over here? IRQ-CR. IRQ-CR register. It is also named Interrupt Control Register, okay? In our code warrior, the code warrior recognizes this name. Of course, if you want to change it, you go to the header file and change it and name it, give it this name. It's up to you. There are only 2 bits here that we need to care about. The IRQ enable, the IRQ edge sensitive. If you make it 1, then you're edge sensitive. You will respond to falling edges. If you keep it at 0, the interrupt will happen in response to a low level. Yani a low level, as long that the pin is connected to ground, an interrupt is going to happen. The enable is bit number 6. If it's 0, then the interrupt is disabled. So this is a mask, a local mask for the IRQ interrupt. But remember, you can make it enabled by making this bit 1. Is that enough? No. The I bit in the CCR register, the I bit has to be clear to enable all maskable interrupts. First, you enable all maskable interrupts, then you come enable this local interrupt. And here is the note that port E bit 1 is shared with IRQ pin. And this is marked on our microcontroller pin number 55. let's talk about sensitivity. What is better, edge sensitive or level sensitive? After we do a demo, how about we do a demo? We learn faster. Then we come to this theory. Let's do a demo. Okay, what do I want to do? Discard. Let's go to our class demos. This is the demo we just opened. The last class demo we did last time. Let me copy it. I'm not gonna start something from scratch. I'm gonna just change some stuff here. Last time we made a count from 0 to 9 on the 7-segment display, right? Class demo 6. Let's go modify the code we wrote last time by adding a push button. So what I'm gonna do, guys, this is the HCS12. This is the push button we already have connected to port M5.
6 or 7.
6 or 7?
Yes.
6 and 7. Okay. You're sure? Okay. أنتوا تحمل مسؤولية. 6.
Yeah. Switch 1 is 6. Switch 2 is 7. Yeah.
Okay. 6. It is connected as per the schematic like this, right? So what I want to do, I already did this before class. I go bring a pull-up register, a 1K pull-up register, for example. 1 to 10 is okay. And connect it to 5 volts from the pins here, the VCC over here. So this pin is always high. When I push the button, it will go to low. What we're going to do in this demo, we're going to do it in 2 ways. First, we want to press the button and read it as a pull without an interrupt. Then I want to go to port E1, which is pin number 55, which is also the IRQ pin. And I want to take a line from here, okay? And when I push the button, see how the same thing happens and makes the button, how the button will cause a falling edge here. It is high, a falling edge, and cause the run of an interrupt service routine to do something, okay? So I'm gonna do some wiring here, a pull-up resistor here, and a wire to port E1. I did it already on my board. طيب. The last time what we wrote here in this program is a counter that counts from 0 to 9 and displays the number on the 7-segment display connected to port H. I want to do something. If I push a button, what can we do, for example? Stop counting and go blink, مثلا, the LED 10 times. Maybe we can do that. Let's do this. I want to do it the normal way without an interrupt, then do it with an interrupt. So if I'm counting at any point of time, I want to push a button. If a button is pushed, I want to blink 10 times, right? So first, I need to define that DDRM equals 0x00, right? Port M, I'm going to make it as input. Port M is input. Then I'm going to check if port M bit 6. How do we check if port M bit 6 is, what happened? Why is this closed? Oh, man. How do port M? It has 8 bits. 1, 2, 3, 4, 5, 6, 7, 8. 0, 1, 2, 3, 4, 5, 6, 7. Right? 0 to 7. So we picked this but PM6, right? The one connected here. actually, I'm not sure. PM6. Where is PM6? I just managed make sure that I picked
PM6 switch 1.
PM6. Yes, here it is. Yes, switch 1. PM6. I want to check if this button is pressed or not. What do I do? If this button is pressed, then its value is going to be 0, right? Otherwise, it's going to be high. So this value is going to be 0 or 1. 0 is pressed. 1 is not pressed. Right? I don't care about the other bits. So what I want to do is mask all other bits by saying port, I think it's PTM, port M, ANDed with 0x 0, so, 1 0 0 0 0 0 0. This is a 4.
Zero.
This is a 0, right? With 4 0. Right? If this condition is true, then the button is not pressed. If it's not true, then the button is pressed. So what I'm going to say, if it's true, yani if this is not this, so yani if this value is 0, inverted is 1, then pressed, right? Pressed. Do what I want to do is when it's pressed. Else, not pressed. And if you don't want to use this, not, just say equals or not equals. صح? You know C better than me. So what I'm going to say here, port M is input. And then I want to read the button. How do I read the button? I say if port M ANDed with 0x40, this is going to be true when port M bit 6 is 1. But I want to do it when it's 0, so I go invert this. I say when this condition is not true. Okay? Now, what's inside here? PM6 push button connected via a pull up resistor to PM6 is pressed. Right? What do I want to do here? First, I need to comment this. If it's pressed, I want to blink port H. Yani, just say port H, blink it 10 times, مثلا. Let's have a counter here. Any counter. Where do I have my I, J, and K? Here. K, مثلا, let's have something called counter. And counter is initially 0. So if this طيب, if this go blink port H, blink it 10 times equals 0x00 to turn all the bits on, right? Then my delay, then turn all the bits off, 0xFF, or I can choose to say this, right? Keep the number. Let's keep the number. Let's keep the number. FF is off. So we know. And keep the number here. Then my delay, right? And we want to do this 10 times, صح? So a for loop for counter equals 0, counter less than 10, counter plus plus. Open here, close here. So do this 10 times, then go back to normal operation if the button is not pressed.
دكتور في براكتس لل my delay.
Yes, here. Thank you.
Doctor, my segment, my 7 segment should be counter, not K. In the loop. In the loop.
No, we can keep, you want to say, no, I want to keep the number that was there before. If you want to display what is the, okay, this could be also counter to see how many times it has been blinking. It's okay. I want to keep the original number. Okay, so let's program it real quick. Then I'll do the same with interrupts. Why does this keep happening? I think I have a bad port. This programming. Let me switch my camera real quick. Guys, at 4:30 you can leave, but I'm gonna continue this this demo for the IRQ.
مش سامعينك دكتور.
You can, do you hear me now?
Yes.
Yes, Doctor.
And you see what, I need to stop sharing. And you see my camera here. Here, right? So this is the counter counting. Now I want to push S1. Here's my button finger. It should, when I push it, it freezes. Maybe let me take out this port M thing. Port M7 or 6.
Switch 1/6.
Let me see what are the buttons I have here. This is what, this is PM, the light, PM6. I took it to a pull-up resistor. The pull-up resistor on the other side is
BM6 جهة السويتش.
Yes, it is. هذا البورت. Can I do this on this? Delay is too high. Remember from last time, I should have done it quicker. صراحة. Let me go back here and make it a little faster, program it again. I'm going back to the code. I'm gonna go do this 100 times, or maybe, I don't know, 50 حتى. 50, starting from anything 3 times faster. Then what happened? It counted to 4. Okay. Program. Okay, see, it's stuck. I need to type reset. Retry. I need to take out the hardware, USB, put it back. Okay, programming. Okay, now I'm gonna turn to run mode over here. Back to run mode, reset, 0, 1, you see it, right? 2, 3, 4 p.m. Now I push the button, nothing happened. Because if I release before, now see, now I kept my finger for a while, a longer time. Now it's blinking, see? It is blinking. It's gonna do this 10 times. But the response to blinking didn't happen when I pushed the button, heck, real quick. I pushed my button and removed my finger. The response was not immediate. I had to keep my finger on the button for a while before I got the response. So when this 10 times is over, we should go back to counting. Now we're back to counting. See, look at my finger. When I'm gonna push real quick and remove it. I did, see, nothing happened because why it didn't respond? See, 0, it didn't respond, see? But if I have to keep my finger for a long time before it catches it keeps the old value and it keeps blinking, see? I had to keep my finger for a long value for a long time before I start getting a response. Let me switch back to I'm back to the screen. You see it, right? You see me. You hear me.
Yes, Doctor.
Okay, I was and my speakers were off. Sorry. So why did this happen? Why did it take time to respond to my command, to me pushing a button? Because I could have probably pushed the button when I was in this delay loop. Pushing the button was not recognized. It's only recognized while I am here. So if I am after this point, anytime over here, you push the button, it's not recognized by the CPU because here we're pulling it. This is the normal way, pulling, not interrupts, okay? I had to keep it for a long time, allowing the program counter to come back and check for this if condition. This is what we mean of pulling, okay? Now let's do the same with the interrupt. Now let's do the same. So let me close this. It is saved and start a new demo. Let's call it demo 7 to keep it for you and do it. So let's do 5, copy 5. And call it 7. And now we're gonna do it with interrupts and see how fast the response is gonna be. So to do interrupts, to remember, you see my screen, صح? You do.
Yes.
We only need this register called int cr, and we need to write a 1 here. يعني ايش? C0 in int control register. That and write the interrupt service routine, which is interrupt number 6. So this is how we do it. We enable interrupts globally, and this line of code is written for us here. If you want to see this enable interrupt, what it is, you can go to macro and see it here. It is calling the assembly instruction CLI. Okay, disable set the I bit. So this is the enable and disable. So we enabled all maskable interrupts globally. Then I want to do it in a function wise, so you can, like a library, you can reuse. So I want to do a function called IRQ interrupt initialize for init, IRQ init. Okay, just so in the future, in your code, in our code, you just call this function, okay, in a library format. Then, so what will be the init, the IRQ init? What do we initialize when we initialize? IRQ underscore init will be what? just writing that register. Just writing that register, int control register equals 0xC0. Enable the IRQ interrupt and make it edge sensitive. طيب
دكتور بس ليش سي 0؟
ليش؟ لأنه here 1 1 so 1 1 0 0 is C 0 0 0 0 is C is 0 صح؟
اوكي.
So 1 1 0 0 0 0 0 0 هذول 0 and these are C, right? Okay. So here we enable the interrupt and we made it edge sensitive. What we want to do before starting our main program or our main loop here, we just call it IRQ underscore init. We just call it once. Yani we could have just wrote that line over here, but it's a good practice for future larger initializations and things to have one function you just call. طيب, the interrupt service routine. The interrupt service routine, you write it somewhere up here before the main program if you want. And you do it like this. Void interrupt handler. You give it the number 6. Where did I get the 6 from? From the table. I got it from the table. Do you want me to remind you? Here. Here. IRQ is number 6. So if I'm going to do a RTI interrupt, real-time interrupt, it's number 7. Timer 0 interrupt is number 8, and so on. طيب. So number 6. Here is what we want to do when an interrupt happens, when a falling edge happens. Happens where? On pin number 55, that is shared with port E1. But see, I'm not going to do anything here regarding port E. I'm not dealing with port E. Okay? What do I want to do when an interrupt happens? I just want to go blink, right? 10 times. I want to go blink 10 times. So I want the count of that here. So unsigned character counter equals 0. Well, K here is a local variable, right? So over here is not going to see it. If I want to keep K as is, I need to move this part outside of the main and put it somewhere here. ماشي. If I want it to be global. طيب. Counter 0. What do I want to say? Port H equals 0xFF. And I'm not going to come here unless we go through the enable interrupt. So before we enable interrupt, I need to make sure that I have configured the direction for port H. So this should be before the enable, right? It should be before. And even it should be before the global enable should be even before the local enable. So we do everything, then enable everything else. ماشي. طيب, back to the interrupt handler, the interrupt service routine. I want to turn off all LEDs on the 7-segment display, call the my delay function, then turn on the LEDs. Well, this I'm going to just copy this. I'm just going to copy this. Turn them on. and repeat this for 10 times. So I need to do this for loop for what is our counter? Our counter is counter equals 0, counter less than 10, counter counter plus plus plus. Okay. Tamam. This will happen for 10 times. Immediate response for a falling edge and on port E1. Let me program it real quick.
بس هذا البروجرام ما فيه port M.
I don't need port M actually, Ahmed. I'm
عشان
not
تكبس الكبسة.
أنا بدي أكبسها. I'm just using the hardware, not the port. Got my idea? I'm just using the wire.
تمام.
يعني pretend it's an external, something external outside. I can do just go take port E and connect it to ground and remove it يعني instead of the button.
دكتور يعني هيك بدك تشبك بوش بتن خارجي مثلا؟
Yeah, push button. بس أنا هون I really am gonna use this one. بس I'm not gonna read it through port M. I'm just gonna use the wire. I'm just gonna.
يعني في واير بين بورت
لا I'm gonna connect it. I'm gonna connect it externally.
يعني من بورت E1 لبورت M6.
M6 yes. Yes.
تمام.
As if the button was connected to E1.
يعني زي كأنه external push button بس نفس اللي installed على الدرايف.
Exactly. Yes. But you can يعني if you don't need a button, you need a falling edge coming from any source, you can do that, right? By just taking the wire, taking it to ground. Okay. What's the problem here? Handler. What's the problem? Maybe this thing, Control X. Maybe let me just make sure. Yeah. What's the problem here? Void interrupt. Void interrupt handler 6. Maybe here. What's going on? Maybe هذا بدي يروح قبليهم كلهم. Control X. Well, can be here. No problem. What's the problem here? Again. Void interrupt handler 6 void.
دكتور ما اقول لازم نعملها زي كيف احنا عاملين الوورد ماي ديلي والار كيو بعدين نحطه بعد حاله بعدين تحت او شيء زي هيك.
لا prototype you do it because if you want to write it down بس now it's here كله هون يعني my delay I can write it fully here without the prototype صح؟
دكتور الهاندلر والسكس اظن ما بزبط يكون في بينهم فراغ.
You
لما
think so?
تعرف ما بزبط.
لا the number is
هي اخذها. لا دكتور زبط راح الايرور بس اعطى ايرور ثاني اللي هي ماي ديلي لازم في لها سيمي كولن.
والله اوكي. السبيس
وماي 7 سيجمنت لازم يطلع على الجلوبال.
okay, you know guys I just remembered my interrupt 6 handler. لا هو هيك interrupt 6 handler is a name you of your choice. Yes, now we got it. You give it the number of the interrupt before the name first. Okay, what else errors do we have? My delay
7 segment لازم يكون globally.
my 7 seg هذا لازم يروح global. Yes, because we're using it. Let's take it global. ماشي over here. هذا warning. Now we can program. Okay, let me just make the delay faster. شو رايكم 50 instead of 150? It was so fast last time. Program. Okay, where's my phone? It is programming. Let me switch cameras. Let me switch cameras. See what happened here. Okay, so let me make this in the run mode. Push the button. Okay, some garbage here, on the 7 segment display. Some garbage. Why? I think it's due to the let me go back to the screen, to the global memory thing. It is due to the global memory thing.
صار انت خلي الاري جوا الجلوبال وجوا المين.
It happened before.
يعني اتوقع كان صارت معي باللعبه assignment 2. طلعت احط الاري بكل مكان.
Well, stupid, صح? Okay, let me. Yeah, it doesn't see the memory location here. So yeah, we can just copy this. Yeah, we can copy this.
اتوقع اصلا بيعطي عليها warning انه مش معمول لها كوبي للمين.
Control C. We can just copy this and put it here in the interrupt service routine.
بجوز كمان تحتاج تحطها بالمين.
بالمين؟ I removed it from the main, صح. يعني it should work though, بس
هو اصلا كانوا بعض نوع من انواع الورنينج انه مش كوبي
yeah. Programming. Okay. Run mode. Reset. Now it works, let me stop sharing so you guys can see. It is counting. Now I'm gonna take port E1, connect it to PM6. Here's PM6. Here I'm joining this and taking this to PE1, which is this bit. Mashi? It is high, nothing happens. It is high. PM6, when I press the button, something happened, but it's not blinking. But there was an immediate response, Immediate response. Not blinking, I don't know why.
just delay عشان delay.
Well, we used the same delay, right? That was counting. We used the same delay that was counting. Let me go back here. We're just debugging, guys, looking for the problem. And this is good to show you that while you guys are working, you can run into any kind of problem. طيب, where is when I push the button, it is clear that we came into here, right? It is clear that we came into here. K is global. Maybe K didn't take K. Let's do this. Instead of K, let's just turn them on, all of them, to make sure to eliminate the probability that K is the problem. 0x00. And we don't have a delay afterwards. We forgot this one, Guys, you saw the problem?
Yes.
So I'm gonna put them back and just add the delay afterwards. Because if you don't do the delay afterwards, طيب.
Semicolon, دكتور.
Semicolon. Program. It is programming. Run mode, run. Stop sharing. It is counting. PM6. Okay. It is blinking, Best slower. It is blinking.
Yes.
See? So K is not the problem. So it's gonna blink for 10 times, then go back to counting. Now, what did you notice here? What is this different here than the previous example?
انه الاوبريشن بتصير immediately.
The response is immediate,
Response,
right?
yes.
The response is immediate. Also, so I'm stopping here, going back to my screen.
Here, sorry. Okay. I hear you, you hear me. Okay, now the response is immediate. Do you hear me, guys? Best yes, no from anybody?
Yes.
Yes.
Okay, thank you. Response is immediate. If you go to the code, see what's different. We did not use port M, right? We did not use port M. And, okay, we did not use port M where the button is pressed. We did not, in our main loop here, we did not check for any parallel ports, right? We don't have any input ports. We don't have anything checking for a button pressed or not, right? Similar to the previous example. Wherever we were, we stopped and the program counter went to execute this code, which stopped incrementing K and blinking the 7-segment display. You can write here wherever you want. I think I'm going to stop here today. Let me stop the recording. If you have any questions, you may stay. Thank you and see you Wednesday.